Welcome. Our final topic in the differential calculus of a single variable are word problems involving extrema. It is applications which ask for the maximum or minimum of some quantity over some situation of interest. So the difference between this and what we did in section 13.2 is that we have to find the function and determine the interval of interest. Another potential complication is that we may not have a finite closed interval. We will talk about that later. First, let's do an example where we do have a finite closed interval. However, I'm first going to make some general remarks, and then in the next session we'll look at the example. Problems involving maximum or minimum, which you can identify by the fact that the question is about finding the largest or the smallest value, or the maximum profit, minimum cost, so on. The first thing you want to do is note down the objective. So what's the quantity of interest, and are you looking for the maximum or the minimum? And then you figure out how that can be calculated. For example, revenue is price times quantity. Purely mathematical problems, often geometric in nature, involve area or volume, and you have to remember the appropriate formula. Now, this formula, or whatever quantity we're trying to calculate, will be calculated based on certain other quantities which are variable. Not all of them might be variable in a given instance. It is also possible that some of them are related, or in the given context they are related. So you are going to list all of those things and use this to write everything you need to calculate the objective function in terms of a single variable. Since we are dealing only with functions of a single variable, we need to do this. In chapter 17, we will deal with the case of several variables. Now for the variable, we want to find the interval of possible values. Going back to items 2 and 4, we want to express the objective in terms of the single variable that we settled on in 4. So now we have a situation where we have a function of a single variable, an interval, and we find the absolute maximum or minimum. In geometric problems, you want to draw a diagram. There's one final trick of trade that might be useful. If your objective function involves a radical, a square root or a cube root or something like that, for a non-negative function, the maximum or minimum occurs at the same point as the maximum or minimum of a power of the function. So if your equation or your function is square root of some expression, you can just find the maximum or minimum of the expression, and then at the end take the square root. So next time we will do a problem goes through these steps.